Hello everybody and welcome to another video of programming for data analytics. Today we're finally going to look at break and continue statements, and then from there I would also like to introduce you to the concept of lift comprehension. It's rather tricky and a little bit complicated for beginners, but it's at least important to understand what it is so that if you run into that code, you know what it does, even if you don't particularly use it yourself in the beginning. So let's do it. Break and continue before something comes up and we change topics again for an hour. So you've learned how to do loops right now. You're loop experts now. You can iterate your code forever and ever. You get infinite loops going and whatnot. And frankly, that's all good. And you should typically not use break and continue in your code unless you have a reason to. So really, me showing it to you today is more of it's kind of like list comprehension. In fact, you could even think of today as being the day of learning code that you will see and probably not use. List comprehension is good to use because it does allow for shorthand, save time writing. Whereas break and continue is something that you shouldn't really use because it makes the code harder to read. But there are some special cases where you might want to use it, and I'll try to cover those. But primarily, it's more of so that if you do see it in the world out there, you know what it does, and you don't freak out and see like, whoa, what does this continue statement mean in the code? So let me give you the basics of what they do first, and then we can just show some code examples. And this should be really quick to go over this, really. So normally when you have a for loop, you can think of the control flow as follows. So let's just have a very simple for loop that goes for I in range of 0 to 100. Okay? And in this for loop, maybe you do some code. I don't know. Let's just say you print the value of I. And then that's it. That's all you do for your code. Okay? And so when you run this code, it's going to basically run, and you could have some code afterwards, like print end, and maybe some code above it. This is print before. Okay, so when you run this code, it's going to print out one line. Every line is going to be 100 lines, and it's going to be the number 0 through 99, right? Because you don't include the 100. So if that's what you want to do, then that's what you should do. If I say, okay, print the number 0 through 9, then all you got to do is change here that value. Cool. Well, there is another way that you can get out of this loop early. Okay? And that's what the break statement is for. The break statement is literally the word break. And whenever you write that statement inside of a loop, whether it's a while loop or a for loop, what it's going to do is it's going to get out of that loop early. If it ever sees that code, if while you're running the code it ever sees that, then it will break out. Now, the way I have this code written right now, even though you have 100 up there, what's going to happen is it's going to print the word before. It's going to go into the for loop. The first value of I is going to be 0. It's going to print out 0. It's going to see the break. And rather than going back to the top of the loop and continuing with I equals to 1, it's just going to immediately print out end. So the output of this is going to be before, 0, end. Now, because I don't want you to be misled into thinking that the break has to always be at the end of the loop, let's just say we had other code in here that said like print stuff. Stuff gets printed, literally. In this case, when this code runs, again the same way, you're going to see before printed, you're going to see 0 printed. So like if this is your terminal, this is something useful to do when you're writing code, like I was showing you last time about all that doing by hand stuff. You can have a thing here that says terminal, and you can write what it should say. So we'll see a before printed here. We'll see a 0 printed here. We'll see the word stuff printed, or will we? We'll see. And then you will see the end printed, right? However, because of the break statement, what's going to happen is you're going to see before, you're going to see the 0, then it's going to see the break, and it's immediately going to exit the loop. So it's going to go to any code that's after the loop if there's any. And if there isn't, then it's just going to terminate. So you're actually not going to see the word stuff printed at all. it'll immediately go and print end, as if the word stuff did not exist. That's important to understand. So not only does break actually terminate the loop, but like it terminates the loop immediately. So like the next statement after break is going to be what's outside of the loop. It's going to ignore anything beneath it, okay? Obviously, if you write this code right here, and that's actually what you like actually put into production, I would ask why you're doing this, because if this is literally the code you're going to run, this break is always going to run. So you don't even need the for loop at all. You could literally just say print 0 and then print end, and then get rid of like the for loop, get rid of the print stuff, because it's never going to be seen, right? So the word break isn't really going to do much for us alone like this in a statement, unless you're debugging. But it'll be more useful if we put it as part of a conditional statement. So if we have an if statement that checks something, so let's say that we only want to break out when the number is equal to 22. So we can say something like, if I is equal to 22, then break. So now what we're going to see happen is we're going to see the word before printed as before. Then we're going to see 0 printed. Then we're going to see 1, 2, 3, 4, 5, and so on until we get to the number 22. So it's going to be like 0, 1, 2, I need more space here, 3, 4, 5, 6, 7, 8, blah, 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 until it gets to 21 and then 22. When it gets to 22, it's going to look at the if statement. Of course, all the other times, when this is the if statement, it's going to be like, if I is equal to 22, it's not, so it skips whatever's inside of the if statement, which in this case is the break. But on this 23rd iteration, when the number that you're looking at is 22, because again, you start counting from 0, then it'll actually go into the if statement because it is equal to 22. And then it'll hit the break. So after that, it is going to exit the if statement and print out end. So even though this loop was supposed to run all the way to 100 and print the numbers 0 to 29 out, 0 to 99 out, it's just going to print 0 to 22. So this is more of an actual case of an if statement that would matter. Now in this case, I would argue that, well, you could do this exact same code if you just go up here and change the number 100 to be just 23. And then you would see the number 0 to 22 printed out, and you would not need to have any of the code here, right? And then of course, the word stuff, I forgot to print that out actually, good point. So there should be the word stuff in between each of these. So 0, stuff, 1, and then you'd see the word stuff, and then 2, and you'd also see it between 21 and 22, but you would not see it after 22, like that. So it would break the pattern. Instead of stuff, you see the word end. So you could do the same thing if you just switch this to 23 here, and then maybe write an if statement that says if I is less than 22, then print out stuff. Otherwise, don't print it out. You could do something like that and not have to have an if statement. And that's kind of how the trend goes. So breaking out of a loop early with a break statement is not particularly ideal because it makes the code harder to read. So when I'm reading somebody else's code, I'm trying to understand what it is, and that's because I'm either taking an example to do some project that I'm working on and I want to use that example code, or I'm part of a company and the company already has some code base and you're trying to add to that code base or use that in one way or form or fix a bug, whatever it may be. If you're looking at other people's code, you want it to be easy to read, and that's why documentation is so important, because sometimes no matter how easy to read you make the code, it's still not going to be easy to read. So that's where documentation jumps in. But you still try your best to make code readable. That's why you choose, and it's not just for others, but also for yourself. So that's why you choose things like good variable names, and formatting is nice, and you space things properly, again with formatting, and more than just naming conventions, you try to split code into tiny pieces that are easy to follow. And when we learn functions, we'll kind of see how that does. But ultimately, you do all these things to try to make the code easy to read, because that makes it code that's welcoming and easy to repair and easy to expand upon and so on. Unless you don't want to lose your job. If you don't want to use your job and you work for a coding company, you make the code as hard to read as possible, because then you'll be the only person alive in this world that can fix that code if it breaks. And so now you have job security, right? That's an ongoing joke with programming. So you don't want to make the code perfect the first time, not because you can't do it, but because if you do, then you're out of a job, right? So no. But anyway, the point is that when you were doing things like break, it sort of, pun intended, it sort of breaks the continuity of the code in the sense that it makes it harder to read. Because now, when I'm looking at this code from top to bottom, as most people do, they look at a for loop and they see that it's going to run 100 times. And you sort of expect that. And you may not necessarily, right now this for loop is made of what is essentially 4 lines inside of it. It's particularly easy to read. You can just look at it once and know what's happening. You see the break statement and you know something's up. But these for loops could have hundreds of lines of code in there. Obviously, that's not ideal, but you could run into a situation like that. There, you might not be looking at every single line in detail, and you might miss out that there's a break statement in there. So when you're running your code, you're confused as to why the code randomly finishes on 22, because you don't happen to see that if 22 break. And it turns out that actually, I believe this will compile or interpret. You can put the if you have a single line if statement, you can do it this way, and the code will take it. So now it's even a little bit harder to read because it's very easy to miss one line of code when you're looking at code. Because yeah, sure, you're looking at the code to understand it, but you're not looking at every single line in detail. It's just too gruesome to do that. So you would miss it. And so furthermore, if you decide that, I only want to print out from, I want to increase this to print out to 33 or less and more, blah, blah, blah. The if statement sort of hard codes this sort of weird situation that happens at a single number. And so it's not convenient and it's not ideal. And even from branch prediction purposes, computers try to make code efficient by predicting what the code is going to be after it. And so if it's easy, you're running a for loop 100 times, and it doesn't know it's running potentially 100 times, but it knows that it's a for loop and it's going in circles like over and over and over again. So it kind of assumes that it's going to keep going. So it just prepares the code ahead of time. Something like a break just totally breaks that pipeline. So it's not ideal in that scenario too. So ultimately, break is just not a good thing to use. It's something that you will see amateur programmers use to try to translate bad logic. So I spent an hour and a half last video, maybe an hour of that hour and a half, preaching to you about how you should develop a good algorithm, develop a good plan, and then implement that plan and make things nice and clean. When you do things like that, you don't have to use things like break. You don't have to use these weird sort of special, keywords that do weird things. You do things nice and clean. People that tend to use these things are things that, you didn't plan ahead. It's like, I have to end this early if it's 22. Let me just throw a break statement to kind of patch my code. And that's just not clean and not easy to read, and it's going to bring more problem in the future. So that's why you don't tend to see often the word break being used in code, and you really should avoid it, because if you're using it, especially if you're using it pretty often, and if the code is relatively simple, such as the code you're writing at this level and stage, it means you're not carefully planning your code and your logic is not the best that it can be. So don't use break unless you have a very good reason to. And if you ever use it, see if there's a way you can rewrite your loops so that you don't have to use it. Okay? For example, let me give you a scenario where you may want to use break though. Let's just say that you may want to, but there's better ways to do it. So suppose that you want to have a loop that is going to just keep doing things. In this case, we're just going to have it print out the word loop. And it's just going to run forever until a user wants to quit by pressing the letter Q. Okay? Otherwise, it's going to just keep asking for input, but that input is just, here, we'll actually print it out. We'll print an echo of that. So it'll print the word loop, and then it'll print out the word. Okay? So might have to kick my dog out. All right. So we'll keep that under the letter I, which is I for input. So I guess we'll just kind of store it there. Okay. So I'm going to go ahead and say something like I gets input. And then just say enter a new letter or something. Enter new letter. And then I'm going to print out that letter. And then the word loop, of course. And then you might be like, well, if they ever enter the letter Q, so I can say if I, which is the letter they entered, is equal to the letter Q, or I is equal to the letter uppercase Q, which you could also use the lower function and just use one if statement. So like I is equal to lower Q, but either way is fine. Then you can go ahead and say break. And because you want this to run forever, you just say while true, which is basically infinity loop. Whenever you run a loop that says while true, it just runs forever. Or it could be a range for loop, like you have a limit, it only runs 1,000,000 times. You know, you can say that. So you're like, well, I want to run something that runs 1,000,000 times. So you say like for, doesn't really matter what you put here, for x in range, it's kind of a throwaway variable. In fact, I believe in Python, you can use an underscore as a throwaway variable. Let's just say it's said 1,000,000 times. We'll just write it 1, 2, 3, 4. Okay. So, you could use this instead of this because you might have that limit. So because yeah, that'll be more of an obvious way of why you're doing this versus like the better way of doing this. Okay. So let's just say you're doing something like this. Okay. So you might be like, well, I got to arrange this for loop, but I really only want to quit in this special case. So, you might be compelled to say, okay, well, I'm going to go ahead and do this, right? And, this could be arguably a decent use of the break statement because of the way you coded the for loop, for I in range of that. However, I would say that a way of coding this without the break, if you still want it to run 1,000,000 times, would be to use your while loop. But instead, so here, this code is perfectly valid. I will do what you want. It'll run 1,000,000 times, and if the user ever enters a queue, it'll terminate. Alternatively, what you could do is use a while loop, use a counter so that you can still do the same counting. Remember, counter goes outside of the loop because it's what you're trying to remember between iterations. So start your counter. Actually, you could start your counter at 1,000,000. And then go ahead and in the while loop say, well, count is greater than 0. Okay, it might be greater than 1. I don't know. Is it going to go? It's including 1,000, so maybe. So it should run when it's 1, but not when 0. So yeah, this is okay. So yeah, that'll do the same thing. And then just make sure that somewhere in here you decrease a count. So you can say count equals count minus 1, or you can just say minus equal 1. Okay, that'll do the same thing as count is equal to count minus 1. Shorthand for that. Okay, if you do that now, then instead of having to do a break here, then you can just go ahead and set count to be equal to 0. You could do something like that. That's one way to do it. If you don't like that at all, if you're still like, oh, well, yeah, but count equal to 0 there, it's kind of still not particularly ideal because, all of a sudden you have a counter that's just randomly going, like skipping a bunch of numbers to 0. I would agree with you that that's also not particularly good code to write. So what would be the ideal solution here would be to use your AND logic. So you can use a Boolean expression that says, well, count is greater than 0 and I is not equal to Q. And you can use it because I think it's lower for that. Actually, here, let's do it this way. Why do I want to lower that? Let's lower the actual variable. So we'll say lower of I, so lowercase I is equal to Q. It's not equal to Q, my bad. You don't want it to be equal. If it's equal, that's when you quit. So if you do that, then you no longer need this. Now I could have put both things in here. So I could have said I could have put like this, and then just flip the logic and say I is not equal to either of these. and switch this or to an and. So usually when you want to flip the logic of an or statement, it becomes an and you flip the two spots to say not instead of like true. So if you have A or B and you want to flip the logic of that, you say not A and not B. And that would be the kind of the, what will give you the opposite result. Oh, we lost the dot from the end. So you could have also used that as an actual condition. So just to show you what that would have looked like, I guess we'll make that one more iteration of this. I think we lost the dots also. There we go. So that would be this, and then we can throw in that with the colon. Okay, so either of those would work. So you could do this, or you could use lower. Let me just verify that lower will work. Just in C++, it's too lower, so I want to make sure. Yeah, lower method. Yep. Okay. I just Googled Python lower, and yalla, I got the answer. So yeah. Okay. So yeah, this I think either of these last two. Wait, what happened to my other one? Oh no, here we go. Yeah, these two. Either of these last two I would consider to be good code, because there's no weird if statement that changes the count, and there's no break statement. We're having our count do the count as normal, but we are saying in the while statement that if I is going to be equal to Q, or uppercase or lowercase, then it terminates. The only last thing you should probably do here to make this work is make sure you initialize I to something, just to avoid weird issues. Like in theory, I is a variable that you've created, but it contains garbage. And in the really odd chance that like that garbage is a Q, the whole thing will terminate, right? So just you know, to protect ourselves, you put something like that in. And once you do that, then you achieve the same thing that you would have done if you were using a break statement, but without it. And this is good code. So this is code that will do the same thing, would function the same way, but it's harder to read, more prone to errors, not as good code, looks amateur. Oh, except for the little underscore on the for. That's kind of cool, because not a lot of people do that. In fact, I think that works, but I'm not 100% sure. I recall that being a thing. This, on the other hand, is good code because there's no break. The while loop is very clear about when this should terminate, which is either when the count is equal to 0, which means it's printed a million times, or when we have a special input in I that the user enters, okay? And if you want to make this even slightly nicer, you could put the I input, the enter new letter up here as well. So you could put this input stuff here, and then just decrease this to count one, be greater than 1, so it prints out one less time. You could also do that too, so that, because right now the way it's always going to go into the loop at least once, which will print the word loop in there, but it depends if that's what you wanted. But ultimately what I'm getting to is, it's all about writing good code to avoid using things like break, okay? When would you want to use break? The only time that I would say for sure that you want to use break is going to be when you're using it because you have two horizontal code. So as you've noticed, when you're writing a for loop and an if statement, every time you got to tab things, so you're like four for loops in, and then you have like an if statement inside another if statement. You have very horizontal code, right? So you might be inclined to try to flatten this code by using things like a break statement. And that I think is okay, but that's a little bit too advanced for this class. So I really wouldn't even do that. Just be aware that there are, don't like automatically assume that if you see a break that like, oh, this person must be a very bad coder or brand new to coding. More likely they are, sure, but at the same time, there are some valid uses for break in these scenarios. In my personal experience, I have done things like this where if I is blah, blah, blah break kind of thing, like I showed you here. Again, because I am trying to not have tons of nested if statements in it. And it's a lot easier to kind of mimic the concept of a case of a switch statement using break. Switch statements is something that other programming languages have, but Python decided not to have. And switch statements are very useful when you have a really complicated if-else statement. So if you have a statement with a bunch of those clauses, it becomes a little bit nasty to write in Python. It's not particularly horizontal because they're just lined up, all of them. But if you have nested stuff like that, it becomes kind of messy. So break can kind of clean that up a little bit. It can also be used, I guess, for like a little bit of efficiency purposes, because if you don't want to check the rest of the code, you can just call a break. Otherwise, okay, so let me give you an example of that actually. Because that'll make more sense. So let's say that you have a code and this code is like you're processing some word. Think of the example that we did last time. And you got a bunch of if statements that process the code, and you got a bunch of stuff, right? Like this. Let's say that at the end of this, you're like, oh shoot, I should check a couple of things before I actually run this. One thing you can do is you could say, well, tab everything one more time, so more space horizontally, then you can do your check. So like if something blah, 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 go ahead and do this. Then you can do another check, another check that you might want to do. So if something blah, 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 then do another error management thing. And finally, if there's no errors, then you can run all this code, right? So then you say finally like else and run that code, right? So you could do something like this. But then what if you need to do other kind of error checking like this over here in this layer? Well, then you got to do the same thing. You got to move this once and then add your extra if statement in there, and then your else if you have one or more checks. But let's just say you have one. So then you do that, and then you do else, and then you run the code. Or you simply say if not, and then do it on the top one, right? Those things make it more horizontal. So I would argue that if what you're working with is just a simple check you need to do at the top of a function or a top of a piece of code, again, we haven't got over functions, but just bear with me. If you have a piece of code and you just need to add one extra check, it might not be worth it just tabbing everything once that way and making the code more horizontal. Instead, what I would do is keep the code here, and then just put your if statement here, and then call your break here. Okay? Now this is assuming that this code is in the for loop that you want to get out. Once we learn functions, the same concept of return would apply here where you would put the word return. And that's probably more of something you would do within the actual break. But yeah, I'm saying if all of this is in some for loop and you need to add one extra check, you could either slide this all by one, or you could just do it like that and not have that extra space. So that would be, I think, a legitimate use of break. Similarly here, you could put the break in there and not have to worry about that, because the automatically else will be beneath it. Okay, so that's a legit use of break, and that I will be okay with. But again, you're not at a stage where you can probably have to worry about this stuff, so avoid it at best. Don't learn bad habits. Okay, that's all about break. That's longer than I thought it would be, to be honest, but we got about 10 minutes left before between last class and this class, they add up to like our limit, so for the week. So let's move on to continue. Continue is going to be kind of in the same idea of this sort of sequence jump things. So let's just start out by putting an example about it. It's kind of, that's the opposite of break in a way. So if you have a for loop again for I in range of 0 to 10, and then you have again your print, just print the L this time, and then print I, and then if you have, if I is equal to 2 mod or I mod, so we'll say if I mod 2 is equal to 0, then I would like to print out the word even. Okay, so this for loop, let's see what it does before we have to continue this. What it's going to do is it's going to go from the number 0 to 10, not including 10. And every time that, and it's going to print out for every number, the number itself after the word L. So it's going to be like L0, L1, L2, L3, all the way to L9. Okay? This extra if statement, though, is saying if the modulus of the value that we have in I If the division, if the mod of that is equal to 0, then print out the word even, because this is modulus operator. So when I say something like 2 or like 6 mod 2, that is basically saying 6 divided by 2 has what remainder? And of course that is a 0. Whereas if I say 5 divided by 2, that is technically 2.5, right? So it has a remainder of half. So that would make the remainder, well, sorry, not 2.5, what am I saying? 2 remainder 1, sorry. Well, I was thinking 2.5. But yeah, 2 remainder 1, which is 1/2, but yeah. So that has a remainder to it. So basically 5 mod 2 is giving you that remainder, so 1. So whenever you do modulus of 2 of any number, what you're basically checking is whether the number is odd or even, depending on if the remainder is 1 or 0. In this case, because we're doing it by 2, if it's equal to 0, then that guarantees that the number is even. Okay? If I did equal to 1 there, then that, if I had an else statement, then I could say that this must be equal to 1, and that would say that would be an odd number. Okay? And so this is basically going to print out the words L0, and then it's going to print out the word even in there. And then here it's going to print out the word even, and even again, and so on. Okay? So ultimately, well, what? Sorry, what am I thinking? It's too late. We're at 1 a.m. at this point. So yeah, I started recording at 10, the last video, and now we're at 1. So I think it's catching up to me here. So ultimately, it's only going to print out even after the even numbers. Okay? So this is a good way of writing this code, and it's acceptable, and it's pretty nice. There's another way that I could write this code that is not as good, but would achieve the same results. I could leave the print to always print out, but in here, I could write the word continue. So what does the word continue do? The word continue, as soon as you see it in your piece of code, like when you're interpreting this, the moment you see the word continue, that iteration of the for loop stops. But rather than break, where it kicks it out of the for loop, what continue will do is it'll kick it back up to the top of the loop. So it kind of brings it back to the top. So whereas break just quits the loop entirely when it sees it, continue only quits that pass of the loop and jumps back up. Now when it jumps back up to the top of the loop, it's as if it had finished that pass. So things like the range base here function here is going to increase I. So like in this case, when I runs with 0 the first time, it's going to basically see 0. It's going to say li here, print that out L0. It's going to see that this is mod 0, which is true. It's going to continue, and it's going to go to the top of the loop, but now I is going to be equal to 1. So you're going to see L1. Then it's going to see the mod 0 will not go there. We'll print out, move the word even. Okay. I think we should have flipped that around. Yeah, we should have flipped that around. There we go. Or actually, we can leave it as it is now. But let's just switch this to say odd in this case. All right, because as you can see, as I was saying, when you get to 0, if I mod 2 is equal to 0, it's going to continue, so it won't print out the word out. But when it's equal to 1, then this will be false, so it will not go to the continue statement because it jumps the if statement off because this is false, and we'll print out the word odd. Then when we get to 2 is even, so it'll go to continue, it'll skip printing odd, and then 3 is odd, so this will not go in, and it will print out the word odd. So basically, continue will bring you back to the top of the loop and will continue. So this could also work at the while loop. And in the case of a while loop, what's going to end up happening is it's going to rerun this expression and conditional expression and evaluate if it still holds to true. So if at some point in the code here it sees a continue, regardless of what's before and after, it's going to run, continue, jump to the top, check this again, see if it's still valid. If it's not, it'll jump out of the loop. But if it still holds to true, then it'll rerun the code until it either finishes that pass or it sees a continue. So you could think of continue as an end early versus break being like I just ended the loop at that point forever. Okay? So again, this would work with continue, but it's like, even now, just trying to look at this, like, why would you do this when I already showed you the simple way of doing it? Well, again, it's all about how you're thinking of the code. Again, it's very easy to fall into this sort of scheme of using things like continue and break because they make more sense logically. Like, okay, if you see something here, stop. And so we can think of logic like that, but there's better ways of doing it, okay? So avoid continue as well. When do you want to use continue? Well, you might have a master program that does a lot of data cleanup, but you might see a spot where like something's already cleaned up, so you don't need to run the code. So you could say, if this is clean, then continue, right? That's one way to do it. Or you could just put the entire thing in an if statement, right? So like, let's say you have some loops code. Again, you only use continue and break with loops, okay? So you have a looped code like this, and then in this for loop or whatever, at some point in the loop, you want to check if data is clean. So you say something like if data, and you have some code, equal to clean. I don't know why you would do this, but let's just say that like you stored a variable that says whether the data was clean or not. If that's clean, then you just want to move on to the next data, so you could say continue. Otherwise, you run your cleaning code. So this is your clean up code. Okay? That's okay, and this is actually a good use of continue. Not for what you're thinking though. It's a good use because of, again, the spacing issue. Because otherwise, if you wanted to do this without continue, here's what it would look like. I would have to flip the logic from saying clean to not clean by putting the not equals clean here. And then once I know that what's inside of this if statement is what to run when it's not clean, then I gotta tab this code. So now I have more horizontal code. Again, right now this code looks, this right here looks nice, but it's probably not like that. It's probably more like that, So the point is that this makes your code again more horizontal. So it's kind of like the same idea as before with the break, except here it's just when you want to just skip this step of the iteration versus like, or this pass I mean, versus like completely just killing the loop. Okay, so you use them both in that form. Most of the time for Python, you're really just going to be focusing on using them for formatting purposes and visually appealing code, whereas not really for actual logic that you need to have it. Like, okay, there's no way I can do this without. I guarantee you that there probably is a way to do it, and it's probably better off. Okay, it's just the code won't look as pretty, maybe. So yeah, that's break and continue for you. Again, they're not particularly tricky. You just and you really shouldn't use them much. Just again, be aware of what they do, so that if you run into code that has it, you know what it's happening, and you're not taken like off guard. Okay. All right. That's break and continue. Let's go ahead and move on to list comprehension. This is again one of those topics that is pretty fancy. It's a Python thing, really, but it's important for everybody to know in case you see it somewhere, okay? So I'm going to leave a reference on the description below to a Python, Geeks for Geeks on list comprehension, which has a lot of good examples. And I'm going to try to not do any of those examples, of course, so that you can get fresh examples, but I am going to sort of go in the same order of concepts that they go on that page, so that you can use that as a reference for additional examples, okay? So as you can see, if you open that page, the first thing that they have is just a normal for loop. And what list comprehension is useful for, so let's start off with that, is you allow it to sort of do shorthand. So, you already know how to do some shorthand, right? We've been using the plus equals or minus equals. So you know that if you do something like this, that can be rewritten as saying sum plus equals 1. And be careful, because if you write this, that's valid code. It's just assigning sum to be a positive 1 though. So it's very easy to flip these two signs, and that's a semantic error that's gonna hunt you for hours until you figure it out, unless you of course run a debugger, then you'll find it quickly, but you got to be careful about them anyways. So similarly to that, we have of course multiplication, division, and all of the operators. You just don't typically do that, right? But this is going to be sum equals sum times 2. So that's just shorthand, and we do it because it's a little bit less writing, and who wants to type more? Also, when you're reading it, it's less reading to do too. So it's a win-win situation. Well, it turns out that you can do a lot of other shorthand writings. For example, like an if statement. you know, if you say if A is equal to B, and you only have one piece of code here that says, like, I don't know, C, some variable C gets 5, you can bring that code up here if it's a single line of code and just put it there, and that's good too. This isn't particularly shorthand in terms of space, or sorry, in terms of like length, but at least in space, you know, it's a little bit nicer. But you're not saving any writing. List comprehension, on the other hand, is all about that shorthand and shorter syntax to be able to handle lists and usually things that you would otherwise write with a for loop. So for example, let us say that we would like to add all the even numbers in a list of numbers, okay? So for example, let's say that we have the following. We have a variable called L, and it contains the following. So it has a 1, a 2, a 5, an 8, a 7, a 3, and a 4. And I would like to write a piece of code that's going to add all of the even numbers in it, okay? Or better yet, let's make a list of all of the even numbers, okay? So I would like to make a new list called EList or EL that is going to ideally contain the 2, the 8, and the 4, and the other numbers not there, okay? So we're sort of cleaning it up. I can do this with what I've learned already. I can declare an empty list, and I can write a for loop that says for I in L, and then I can go ahead in here and say, you know, if, let's say, I mod 2, as we saw, is the way to assess whether something is even or not, is equal to 0, then go ahead and add it to the new list. So you can say el dot append I. So you can do something like that. Okay? So this code is nice and it will do what I want, but you have, of course, two downsides to this code. One of them is, as you can see, it's very horizontal. We keep talking about that. That's the theme of the day, is all this horizontal code. And more importantly, it's a lot of writing. Okay? It turns out that you can simplify this code by using this list comprehension magic. Okay? And so let us go ahead and try it out, because this stuff is tricky enough that I would like to actually code it myself in case I make a mistake. Okay, so we're going to make a new file, 16.py. And I didn't show you any code with break and continue, but I mean, you get the idea. It's pretty much what I showed you. Yeah, don't worry too much. Try it at home. Try writing some code with break and continue. I mean, I did show you code, but I just didn't run it. That's the for loop, and then let's go ahead and throw in the numbers. So I already have an idea for using more list comprehension. Actually, we can make a list comprehension that actually inserts number for us. So yeah, but okay. So here we go. We got some code, and just to see if this worked, we can call print at the end of this, and just print out the list. We run it, and we can see that we get 2, 4, 2, 8, and 4. Okay, so it does what it does. It's not particularly bad, but like I said, there are shorthands. Which again, I don't expect you to use this, but I expect you to know it so that if somebody else uses it, you're not like, what the heck is happening in this line of code? Like, is this black magic code or something? No, you'll see it and you'll be like, oh, they're using list comprehension, and then you can actually understand it. So if anybody ever wants to show off, they'll probably use list comprehension. So we'll call it new list, ML. So let me show you how I think that you could do this in one line of code. Let me just write the line of code first to make sure that it'll work, since this stuff can be tricky, and then I'll explain it. So for I in L, if I mod 2 is equal to 0. Okay, and if we print it out, it should be the same thing. Yes, I got it right. Okay, ooh, scary stuff. So, first of all, before I even explain to you what happens, look at this, and look at this, including that line actually. So 4 lines of code have converted itself into 1 line of code, which has way less writing, way less spacing, because there's no horizontal code, nothing, and it does the exact same thing. And furthermore, I think Python will actually optimize this to maybe even run faster. This is list comprehension. Now you might be like, whoa, what is this? In fact, if I just flat out wrote this line of code, you didn't see anything but that, and I started class that way, you'd probably be like, oh no, what did I miss? But if you see this and this, hopefully you kind of see the similarities. And I try to use the same variables to show you that. But I could have used different variables here, like XX or something. So let's break this down, okay? So what list comprehension does is it builds a new list from other data. And so in this case, from another list. So what is happening here is usually the way the list comprehension kind of runs is you usually use it to simplify a for statement. Okay, so a for loop. So in this case, we have a for loop right here for I and L. It's literally the same one as you can see it highlighted up there. That's your for loop right there. So that you're not saving any time with that. However, what this does is it will append this information that this returns into this new list that we're making here. And the rules for what it will append and what it will not append are what you put as a third piece of code here. So I am saying if I mod 2 is equal to 0, so if the number is even, then actually append it. Okay? So there's 3 parts here. This is to be part A, part B, and part C. Part B is usually going to be the same regardless. It's just your for loop for I and L, for I and whatever. This is your inside of your for loop and what you want to do as a check. You don't need to, by the way, have a check in here, but usually you want to have some kind of check because that's why you're doing this. You're trying to only extract certain elements from a list. So in this case, I'm only extracting the even ones. If I wanted to extract the odd ones, I would change this to a 1. Finally, this part of the part A, I guess, of the list is what you're actually going to generate and store if this evaluates true. So this is your append. Okay? If I go in and add a +1 here, you will see that instead of storing 2, 8, and 4, it's going to store 3, 9, and 5. Because what I'm saying is, okay, if this is a number that we actually want to store, rather than storing that number itself, you can store other pieces of data, including not even the number. You could store like a 0 in there for all it cares. I think it'll build. I put a 0, that's going to store a bunch of zeros, right? So that's deciding what you want to store and how you want to store it, because you may want to modify the data in one way or form. This is merely checking if the data is something that you care about for this list, and now that you know that you care about it, do you want to store a copy directly, or you want to modify, you want to divide it, multiply it, do whatever you want to it before you store it. And that's list comprehension in a nutshell. You may have to rewind and watch that piece of the video a couple of times to get that, because I do understand, I do remember when I first learned Python that list comprehension was one of those things that took the longest time for me to follow. And even today, sometimes, you'll see some list comprehension examples that are like really trippy. You have to like look at them. I would argue that list comprehension does make your code harder to read, and you really should avoid to use it unless you have a good reason for it, which is, again, you're really writing a lot of code and you're trying to, save some pain on your fingers, I guess. And also, if you're trying to compress some code, you're trying to impress someone, I suppose. But for the most time, a lot of people have a hard time with this. So you don't do this for code that is mission critical, that people have to understand how it works, because they won't. And then it's going to cause problems down the pipeline if people don't understand the code that you're writing. So list comprehension is definitely awesome in that it saves you time if you really understand it and can do it quickly. As you can see, me writing this code, I had to think for a little bit. So whereas this, it just comes out. So, pros and cons. So, but at least know how it works and be able to break it down so that you understand it. So you can fix it if you have to, or if you have to modify it to serve your purposes, you can. In the example on the Geeks for Geeks, they are using, whether something should belong to something else. So like, for example, in the case that they post there, they have like apples and bananas and a bunch of things. And they say for this and that, if so they're checking whether there is a letter found in each one. So let's do an example like that. I don't want to do the same one because you can just look at that example yourselves. But they're saying, okay, we're going to do a list of, let's do cars since we're doing fruit, and let's put a bunch of brands of cars, not cards. So Toyota, let's do BMW, Mercedes, Volvo, Tesla, Kia, I guess it's a brand. What's like a really old brand? Well, Ford. Yeah. Okay. All right. So, what if I wanted to find in this all of the brands that contain the letter O in them as part of a letter? Okay. So I could write a for loop and say something like, for each of these, so for each brand, so for brand in car, car brands, maybe use a better name for that variable. For each brand and car brand, if the letter O is found in the brand, then go ahead and append it to this new list of brands with O, which we'll just call O brands. So you can say O brands dot append and then the brand. Okay, and if I do that, and then I go ahead and say print O brand. And actually, let me do that after these prints. For brand and car brands, plural. And by the way, I don't usually do this, but I should. Look at the errors, because I do want to also teach you how to read errors and be aware of what they're a lot of the times they're very nice. Like, look, name car brand is not defined. The reason why this is happening is because the word car brand is, of course, misspelled. The variable name is car brands. So it's actually looking for a variable called car brand, and it doesn't find one in the program. So it's like, this variable doesn't exist. Now, usually when you get that error, it's because you wrote a variable that doesn't exist because you did a typo, as I did here, okay? But understand that that's why it's saying not defined, and that the error is actually good because it helps you fix the code. So read the errors and Google them if you don't understand them, because you'll usually find good documentation online about them. So here we go. All of these have O's in them. As you can see, BMW is not there because there's no O. Okay? So what will be the list comprehension version of this? Well, this time around, let's actually print it out. So let's not, of course I could do something like, random list R and then do the list comprehension here. Let's actually just call the print directly here, since we don't need to use it anywhere else, and do the list comprehension here. So I can go ahead and say, and of course I can, you don't have to write the word brand. I can shorthand it here. After all, this whole thing's all about shorthanding, but this is where it gets to that borderline of like, list comprehension is kind of working against you and making readable code if you don't at least name variables, okay? But at the same time, why would you do it if you're not trying to, if the whole reason you're doing it is because you were trying to write less, right? So let's go extreme with that. So let's say B, and then we'll say for brand and here you can't get around not putting the entire list name, and then put your if statement. So we only want to add it if there's O in there. So we say if O in B, which is my brand. Okay? So there you go. You don't need these spaces, but I put them there just to make it easier to read on the eyes. But technically, since we're doing list comprehension again, you're trying to make this as tight as possible. Let's not do that then, I guess. Okay? So there we go. So B is just my brands, which I shorthanded. So B is what we're going to return. And again, this is for B in car brands. So that's this. That matches this. And then this here. I don't like that. I do want to have space. If O in brands is this part here, and the append is just that. We're not doing anything other than appending. If I was appending and also adding the exclamation point like that, then sure, I could do that here by putting an exclamation point. But you don't have to do anything. You can just append it normally. See that? It's appending it. But I can also just get rid of that and just append it like regular. Okay? But you'll see that this will do the same thing, a lot less writing, but questionable in terms of like readability of that code. Okay. I believe that the syntax that Geeks for Geeks gives, I do like that one, so I'm going to paste it here for you, is that. And actually, let's write that one in the notes too. Because I do want to, maybe at the end of the semester, publish this as a PDF for all of you to have when you go out in the real world. You can remember the good times that you had with me and look at the PDF of all the notes. And maybe that'll trigger some memories. So really here, what you're doing is the new list is equal to, or again, you just immediately put it in a function like print or something. And what you're going to do there, I'm going to put in the next line because I'm going to run out of space here, is you have the expression that you're trying to store there, but you can modify. Again, it's an expression. And then you have your for, and then you have the item that you're going to iterate through from the list, which is an iterable. So the only iterable that we know so far are lists, but there are other ones that we will learn later on, like tuples and whatnot. What? Iterable? Well, dictionaries. Yeah, sets are the ones that are not. No, actually, no, you can iterate through all of them. I know for sets you can iterate, but you can get them in random order. Forget about that. I have to refresh my mind on that. Plus, we're not there yet. Okay? And then you also have your if statement at the end. So you have your if condition is true. So that together is what makes your this comprehension. Okay. Shrink this enough that it'll fit in one line. Like that. Okay. And again, this is one of the components. This is the easiest component, the for loop, because it's just literally going to be the exact same thing you would write as a for loop. There's no colon there. And then this is your if statement, which again is nothing fancy. I mean, you can make it fancy, but I'm saying it doesn't have to be. The expression is whatever you want to append. Okay? And you don't have to, I guess, yeah, Geeks for Geeks does mention that. You don't have to actually have all components here. So you don't actually need the if statement if you just want to append everything. It's just that it has less usages that way. So for example, suppose that I wanted to take, I wanted to take all the car brands and just make a brand new list that is a copy of them. You can do that by just writing a, another, we'll call it another list. And it's just going to have, let's get rid of that. X for X in car brands. And then no if statement. And this is literally just going to make a copy of the list. But then you might ask, well, why would you want to make it a copy? Well, you might want to, you want to duplicate to modify it. But maybe you want to add that exclamation point that I was mentioning earlier. So like, let's say you have a list and you're like, oh, I like my list, but I really want to add 1 to all of the numbers, or I want to do this, or I want to do that. Well, you could do that there. But here, I just made a variation of the list with exclamation points added to that. It's pretty cool. Or maybe I want to make a version that has everything lowercase because I'm cleaning up my data. That's actually a more relevant example to our purposes of this stuff. So lower is not defined. Lower is not defined. I thought lower was going to work for lowercasing stuff. That's what we said earlier too. That's strange. It's not a string? Okay, maybe it's that way. Okay, apologies for earlier when I said lower that way. Let's fix that. Wasn't that today, or was that? Yeah, here we go. So then this should be I.lower. There we go. Okay. So I'm glad that we got to fix that in the same video. I have to like correct the video or something. So yeah, so now this version will lowercase everything. So it will lowercase. Oh, I'm sorry, you didn't see that. Let me switch over to that, to the iPad. So what I fixed was up here in the in this one. So what we had before was actually that, and of course that we saw does not work. So instead it's I dot lower. Okay, don't worry too much about the dot. Again, when we talk about classes and structs and that kind of thing, we'll explain why the dot works like it does and what the parentheses mean with functions and whatnot. So, yeah, but yeah. So basically, there is no necessity to have the if statement if you're just trying to do everything to make a copy of all the data, but maybe modify it in one way or the other, such as cleaning it up, etc., etc. I challenge you now. You don't have to do this one as an assignment, but I challenge you now to take the code from the last video when we're trying to do the numbers and the letters and whatnot, and modify that code and use list comprehension for it. And I think that'll be a very interesting exercise for you to do. I encourage you to do it. I'm not going to make you grade it because, again, I'm not a fan of list comprehension, but it's good for you to do. And again, list comprehension doesn't just work with list. It's going to work with tuples, sets, and other things that we'll talk about. We haven't talked about them yet, but we will. Okay? You can also make your own iterable by using range. Just like you can write a for loop that says for I in range of something, you can do the exact same thing with the with list comprehension. So, like for example, if I want to make a list of numbers for I in range of 0 to 100, of course, if all I want to make is a list that contains like all numbers that are divisible by 3, I could probably just use a step function in the range loop. Okay, or here actually, let's just say yeah, that's what I would do, but yeah, that's fine. Let's just say that we want to say if let's just do even. No. Yeah, let's do even. Let's just say if x mod 2 is equal to 0, then I want to say L dot append I, right? And well, I can't really increment this by different steps because no, I can't. So let's just say increment in steps of 5. All right. Yeah. Okay. This is pretty nice code. So let's see what that list will look like. So we get 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Yeah, because of the okay. Screw that one. This is 7. More interesting. Okay, that's a little more interesting. Kinda. It's multiples of 14. Understandable why, but yeah. So you could probably do this without the mod if you do your step doing 14, which defeats the purpose. But anyways, the point is, let's say you write the piece of code and you want to make it into a iterable. So let's say that into list comprehension. So all you gotta do is do something like I for I in range of 0 to 100, step 7. And then write if I mod 2 equal to 0, and that's it. And if you run that, you will see that you get the exact same numbers. It's literally like the same thing. Like, look, this is your for loop right there. It's been highlighted. This is your if statement, and then this is because you're just appending it raw. If you're not, if I wanted to append like the number plus 1, I would do it here. So that's the same thing where I would do here. And there you go. Same thing. Okay. You can hardcode what you're entering again, like I showed you with zeros and whatnot. But yeah, that's pretty much it. And of course, you could do this stuff can get nasty. So you could do list comprehension inside other list comprehension, like list comprehension inception. That's I don't think I'm gonna even cover that, but I want you to know that this goes down deeper in that rabbit hole. You can do some pretty nasty stuff, because at the end of the day, this is just a list. Here, let's do a very simple example of that. So let's just make a tiny little list that gives us the numbers 1 to 10. Okay, so that would be something like, well, we're going to store this in the variable for now. So we're going to say x for, oh, sorry. By the way, it has to be I could do x if I wanted to. For x in range 0 to 10, well, let's include 10. That's just a very simple list comprehension, okay? Just very simple. Just so I can show you the nestedness, okay? So you can see right there, you got all the numbers in there. Now that you know that works, what I'm going to do is, I'll make it simple. I'll make it so it doesn't look as nasty first, but then I'll make it look nasty. So let's do another list comprehension that's only going to store the even numbers, okay? From there. So, I will do something like x, or here, let's do I for I in V, because that's where our current list is, if I mod 2 is equal to 0, like that. So I know that one's going to print out the even numbers, right? Well, now let me show you how it looks combined. So I can combine this with the top one by literally copying and pasting this into V right here. Okay? If I run it, you'll see that I get the same result. So really, I'm doing nested list comprehension. Here, it's kind of it's easier to see because I do one of them first. It's in B, and I just put the B in here in that in part, that for X and this or for Y and this. Whereas here, I'm literally putting that entire piece of code there. So yeah, and the same thing here. This range here, this could be another list. So I could go deeper and deeper and deeper and deeper into this, into like 10 layers deep. Which again, at that point, I question as to whether this is a good idea, because no one, even yourself included, is going to be able to understand that code after you go to sleep and wake up the next day and you're like, holy crap, what have I done? So it's nice that you can do it. There are some very valid cases, and again, it saves you a lot of work for trivial code, but be careful that you don't write code that you yourself is not even going to remember what it does the next day, because you were just trying to impress yourself. So with that, I believe we finally had a lecture where we actually did what we said we would do, but that's fine. At the end of the day, these are all very useful steps in your path to be able to program for data analytics, as the course name is, because these are all very important tools that you want to be able to use whenever the necessity comes up to them. Okay, so thank you all for watching, and I hope that you learned what to do and what not to do today, because again, avoid things like break and continue, but understand them so that you know if other people use them, but you don't use them unless you have to or you have a good reason to. Which again, if you're watching this, you're learning how to program, so avoid them, okay? There will come a time when maybe they'll come in useful. For now, just avoid them. Know how they work if you see them, but avoid them, okay? And with this comprehension, try it out occasionally. Understand it enough that you can, again, understand other people's code, but don't feel bad if you don't use it in the beginning. It's one of those things that later on, you might see it as a thing that might help you grow and code faster, but it's not particularly something important that you should just be doing. Like, oh, I'm so hyped, I'm going to do every single for loop with list comprehension and whatnot. No. Don't worry. The time will come. For now, just take it easy, learn the basics, understand them, become good, and then you can start doing code optimizations and other fancy things. Okay? But of course, have fun. Enjoy it. After all, coding should be fun. Take care, and I'll see you next time.